What about the groups? If you count them, you will find that there are total 18 groups are there. So these horizontal rows of the periods, they are numbered from 1 to 7, whereas groups are numbered
Hello.
from 1 to 18.
Hello.
And hello,
Ma'am, can you please repeat all the things?
uh, okay, from the beginning,
Yes, ma'am. From your introduction to.
okay, 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 no problem. Uh, 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 can I start? Uh, काय करू? Stop share. Shall I start, sir?
Yes, yes, ma'am.
Okay. Good morning, students. I am Miss Madhura Vasant Sahani, and I am from Kirti College. This is your chemistry lecture, and today this is your chemistry lecture. Today we are going to begin with your seventh chapter of your chemistry textbook, and that is nothing but modern periodic table. Now, students, you know about the elements, correct? So up till now, there are total one elements were known, or you can say that up till now you know about there are total one elements are there, right? But in the early 19th century, there are approximately only 30 elements were known, and they were classified as metals, non-metals, and metalloids. Later on, few more elements were discovered, and scientists tried to classify them on the basis of their atomic masses. You also know about the concept of Dobenius triad and the Newton's octave. But do you know that further more elements were discovered, and it's become very difficult for the scientists to study them individually. And because of that reason, there's a need to classify them as per their similarity or as per their properties. And because of that reason, this concept of periodic table was put forth by the scientist Mendeleev. So what the Mendeleev has done, he has arranged the 63 elements which were known at that time. See how such a large number is there. So he arranged those elements in his famous periodic table, and his periodic table was totally based on his periodic law. So what was that law? The law states that physical and chemical properties of the so uh, he okay, uh, okay. So what he has done, Mendeleev has arranged this. What he has done, his periodic table was totally based on this periodic law, and the law states that physical and chemical properties of the elements are periodic functions of their atomic masses. So, in the today's lecture, what we are going to do, we are going to learn about the Mendeleev's periodic table very briefly, and then we are going to start with modern periodic table, and we'll go further ahead in our topic. So, I have already shared my screen with you all. So, let us begin with our topic. Okay. Now, just look at this Mendeleev's periodic table. See, this Mendeleev's periodic table is basically, it consists of vertical groups and the horizontal series. Now, how Mendeleev arranged the elements? So he arranged the elements in the increasing order of their atomic masses. But the ordinal number or serial number of the elements he referred as an atomic number. What about the properties of those elements? So the elements which are belonging to the same group, they show similarity in the properties. But as you move down the group, they show similarity in the properties. But the elements which are present in the horizontal series, they show some gradual variation in their properties as we move from left to right. Further, we can say that, can you observe that here there are certain gaps are present. What about those gaps? So, when the Mendeleev constructed his periodic table, he left out certain gaps to maintain the periodicity of the properties. So, later on, when the new elements were discovered, they got well fitted into those gaps in order to maintain their periodic properties. However, Mendeleev has not predicted about the inert gases or the noble gases, but see, when they really got discovered, they got easily accommodated in the new periodic table just by creating an additional group. So these are all about the merits of the Mendeleev's periodic table. However, Mendeleev's periodic table has got a certain demerits also, and his demerits were overcome because of Moseley's X-ray spectroscopic work. So what he showed, so Moseley showed that frequencies of the X-ray emitted by the elements, they are fundamental properties of atomic number Z rather than atomic mass. And because of that reason, that Mendeleev's periodic law get modified to modern periodic law. So what was that law that we'll study in the next slide? See, the law is totally based on the atomic numbers, and the law states that physical and chemical properties of the elements are periodic function of their atomic numbers. So based on this law, there is a modern periodic table, or the long form of periodic table is there. So let us start with, or let us study the characteristic features of the long form of periodic table in the next slide. Okay, now just look at the slide. See, this is what about your long form or the modern periodic table. Now this modern periodic table is basically, it consists of, see, these are the horizontal rows or the periods. So it consists of horizontal rows or the periods as well as vertical columns, or referred as groups. Now, if you count these horizontal periods, you will say that there are total 7 periods are there. Similarly, if you count this group, you will find that there are total 18 groups are there. So, numbering of the periods is done from 1 to 7 and the groups are done from 1 to 18. So, this numbering of the periods and the group, it is recommended by IUPAC, that is International Union of Pure and Applied Chemistry. Now, further, if you look at this periodic table, you will you can find that these horizontal rows intersect the vertical columns or the groups into number of boxes. Into each box, individual element is placed. There are total 118 boxes are there. So as definitely 118 elements are there. See, however, out of 118 elements, some of the elements are man-made, but their names and the symbols, they are completely approved by the IUPAC. Further, if you look at the table, you will find that just below this periodic table, there are two series, each containing 14 elements are placed. Further, you can say that this periodic table is divided into total 4 blocks. And what are those 4 blocks? S block, P block, D and F. So let us study those S, P, D and F block, how they get divided into the next slide. Now see here. If you look at this periodic table, just see here on the extreme left hand side of the periodic table, can you find there are 2 groups are present, group 1 and the group 2. They basically form S block. If you go towards the extreme right hand side of the periodic table, you will find there are total 6 groups are present, numbers starting from group 13 to 18, and they basically form P block. Whereas just at the center or the middle of the periodic table, there are total 10 groups are present. They begin from group 3 to group 12. They basically form D block element. And just below this periodic table, you will find there are 2 series, each containing 14 elements are present. They basically form F block element. So these are all about the characteristic features of the modern periodic table. So in the next slide, we have summarized, or I have summarized these characteristic features of the modern periodic table, or another name is long form of periodic table. If you want to take a screenshot, you can take it. Now I just want to tell you What are the ways of asking question in your exam on this particular part? See, if you are getting the 3 marks or the 4 marks question, you may get a question. Write down the characteristic features of the long form of periodic table or the modern periodic table. Also, you may come across with a multiple choice of question on this. That is, what are the numbers of periods or the groups? You have to remember this. 1 to 7 is the periods and the 1 to 18 are nothing but the groups. So these are the different ways of asking question, which is based on our long form of periodic table. Further, one more question can be expected in your exam. What is the position of S block, P block, D block, and A block as per the long form of periodic table or as per the modern periodic table? Clear about this part? So we have covered what are the ways of asking question, and we'll go ahead in our topic. So in the next slide, we are going to learn about the electronic configuration and the periodic table concept. Now see, what about the electronic configuration of an atom? See, electronic configuration of an atom is the distribution of its electrons in orbitals. See, this is a new concept for you. What do you mean by orbitals? Just take off, just remember that orbital is nothing but it's the three-dimensional space around the nucleus where probability of finding electron is maximum. I'll repeat, orbital means it's the three. You have to just imagine that part. This everything is imagination. It is based on imagination. So orbital is nothing but it's a three-dimensional space around the nucleus where probability of finding electron is maximum. So you are going to learn EC. EC is a short form, electronic configuration in the periods, in the groups, and the 4 blocks. 4 blocks and a SPDF. But before you learn the EC in case of periods, first of all, you should know the concept of shell, subshells, and orbitals. So that we are going to learn in the next slide. Now, just look at this diagram. It is about a diagrammatic representation of structure of atom. You have to remember this diagram throughout this topic till we complete the entire topic. And it's very easy to remember the diagram. So this is about the structure of atom. Atom shows presence of nucleus at the center. Nucleus show presence of proton and the neutron. Neutrons are chargeless, protons are positively charged. Therefore, entire nucleus is positively charged. Now, this nucleus is surrounded by stationary energy levels, which are referred as shells or the orbits. These energy levels, they are represented by the small n symbol that is nothing but C, principal quantum number. Further, these shells, they are designated by fixed letters K, look at my laser, K, L, M and N. So, when n is equal to 1, principal quantum number n is equal to 1, you know, this is your first shell, that is K shell. When n is equal to 2, this is your second shell, that is L shell. When n is equal to 3, this is your M shell. Third shell, when n is equal to 4, this is your fourth shell, that is N shell. So, now here you have learned the concept of shell, that is K यानी first shell, L यानी second, M यानी third shell, N यानी fourth shell, when n का value is 1, 2, 3 and 4. Further, you should know that shells show presence of subshells. What are those subshells? There are total 4 subshells are there. S, P, D and A. See, though I am saying shells show presence of 4 subshells, S, P, D, F, that doesn't mean each shell show presence of all the 4 subshells. No. For each shell, subshells are fixed. Therefore, for this K shell, there is always one and only one subshell, that is S. When you go for the L, that is second shell, always there are 2 subshells, S and P. When you go for the M shell, there are 3 subshells are possible, S, P and D. Here, I want to make you one more concept clear. Though we say that for the M shell, there are 3 subshells are there, that is S, P and D, S, P and D. When actual electron filling is done in the subshells, You know, the electron filling is done in S and P subshells, but not in the D subshell in case of third shell. It is as per the above principle, but that you will learn into the detail when we'll go ahead when we learn the actual electronic configuration in the case of P-rate. So now, at present, you have to remember that for the M or the third shell, three subshells are there, S, P, and D. What about the A? That is the fourth shell. For the fourth shell, there are total all the four subshells are possible. That is S, P, D, and F. So here you have learned the concept of shell and the subshells. Like K has got only one subshell S, L has got S and P, M has got SPD, and the fourth shell has got SPDA. Now, these subshells further show presence of orbitals. Now you have an idea, orbitals and what? It's a three-dimensional space around the nucleus where probability of finding electron is maximum. That means now you have an idea, when we are dealing with the orbitals, you are going to find out how many electrons are accommodated into each orbital. So let us switch over to the next slide. Here we are going to learn about the concept of subshell and the orbitals. See, four subshells S, P, D, and F. What about the orbitals? Here, generally we represent the orbitals in the form of box. So S has got only one orbital. P has got total three orbitals, 1, 2, and 3. D has got total 5 orbitals, 1, 2, 3, 4, and 5. Whereas F has got total 7 orbitals, 1, 2, 3, 4, 5, 6, and 7. So always S याने 1 orbital, P याने 3 orbitals, D याने 5 orbitals, and F याने total 7 orbitals. Now the very important thing that you have to remember throughout the year, that an orbital can occupy maximum 2 electrons at a time. Very important statement. This concept, even it is useful when you learn the topic structure of atom also. An orbital can accommodate maximum 2 electrons at a time. So this S orbital will accommodate maximum how many electrons? 2 electrons. See, if one orbital accommodates 2 electrons, P has got total 3 orbitals. So how many electrons are accommodated maximum in the P? Obviously 6. So similarly, in the case of D orbital, as there are total 5 orbitals are there, each accommodate maximum 2 electrons at a time, and therefore D has a capacity to accommodate total 10 electrons. F has got total 7 orbitals, so F का capacity to accommodate maximum 14 electrons at a time. So here we have learned the concept of shell, subshells, and orbitals. So now we are going to switch over, or we are going, by making the use of this concept, we are going to learn about electronic configuration in the case of period. So let me go ahead with our slide. Now see here, electronic configurations in the period in the case of modern periodic table. You know that there are total, 7 horizontal rows of the periods are there in the long form of periodic table. This period number n, it indicates, or it corresponds to principal quantum number of the valence shell or the outermost shell. What I said, this period number, yani 1, 2, 3, 4, 5, 6, 7, it indicates principal quantum number of the valence shell or outermost shell. What do you mean by that? Meaning is that in the case of period number 1, try to recollect that diagram. It has got one and only one K shell. You recollect that diagram, nucleus at the center surrounded by stationary energy levels for orbits. Orbits are designated by principal quantum number n. When n is equal to 1, it is your first shell, K shell. When n is equal to 2, it is your L shell. When n is equal to 3, M. N is equal to 4, N, and so on. So, by referring to the diagram, you know that for my first period, means when n value is 1, there is only one K shell is there. But in case of second period, now you will tell me it has got L shell. See, referring to diagram, you are going to tell me, yes, it has got L shell. You are correct. But see to it that this L shell is your outermost shell or the valence shell. In the sense what? For the second period, K and L, both the shells are there, where K is your inner shell, L is your outermost shell, because we are dealing with the EC in case of periods with respect to outermost shell or the valence shell electronic configuration. Therefore, for the first period, K shell is there, but for second period, K and L, both the shells are there. K is your inner shell, L is your outermost shell. And therefore, if you look at the table, you will find that here atomic number of the element they increases by 1. See, hydrogen का atomic number कितना है 1, helium का कितना है 2. In the next period में lithium का कितना है 3, beryllium का कितना है 4, boron का 5, carbon 6, nitrogen 7 and so on. So as we move from left to right in the periodic table, the atomic number increases by 1. Means 1 electron gets added to the outermost shell or the valence shell of an atom. So the electron filling always begins with the S subshell and it ends with the P subshell with a completed octet, except in case of period number 1. In case of period number 1, it satisfies the condition of the duplet. Now what do you mean by that? हे मी आपण आता हे जे लर्न केलं ते आपण काय लर्न केलं? आपण आता हे असं शिकलो की तुम्ही जेव्हा पिरियडिक टेबल बघता तेव्हा ॲटॉमिक नंबर जो आहे तो एकेकाने वाढतोय. हायड्रोजनचा 1 आहे, हेलियमचे 2, लिथियमचा 3 झाला, बेरिलियमचा 4 झाला, बोरॉनचा 5 झाला. एक एक ॲटॉमिक नंबर एकाने वाढला याचाच अर्थ जो एक इलेक्ट्रॉन जो ऍड होतो तो कुठे ऍड होतो? ऍटमच्या आउटरमोस्ट शेल मध्ये. कारण इसी जेव्हा आपण पिरियड मध्ये शिकतो, वी आर डिलिंग विथ द व्हॅलन्स शेल ऑर द आउटरमोस्ट शेल इलेक्ट्रॉनिक कॉन्फिगरेशन. म्हणून आपण असं बोललो की जेव्हा तुम्ही पहिला पिरियड घेता तेव्हा हायड्रोजन मध्ये एकच शेल आहे म्हणजे के. पण जेव्हा तुम्ही दुसऱ्या पिरियडला जाता तेव्हा तिकडे के पण आहे आणि एलही आहे. के असल्या कारणाने तुमची आतली शेल झाली आणि एल आहे ती तुमची बाहेरची झाली. याचाच अर्थ काय? दुसऱ्या पिरियड मध्ये पहिल्यांदी कायम के शेल भरणार आहे. जसा जसा तुमचा ॲटॉमिक नंबर वाढत जाईल एलिमेंटचा, जसं तुम्ही लेफ्ट टू राईट जाणार, जो जो इलेक्ट्रॉनचा नंबर वाढत जाईल आतल्या शेल्स परत भरत येतील आणि जो बाहेर जो एक इलेक्ट्रॉन राहतो तो टर्मोस्ट शेल मध्ये ऍड होतो. समजलं? हे आपण इथे शिकलेलं. सो वी आर गोइंग टू लर्न फर्दर मोर अबाउट दिस along with the examples in case of all the periods. So let us go ahead with the next slide. There we are going to learn the more concept about this K and L shell ka, because this concept should be completely fit in your mind so that you will not get confused while writing the EC also. So now here the same thing with what we have did. In the case of period number 1, hydrogen sa atomic number kitna hai? Z is equal to 1. So this is your nucleus, this is your K shell. So one electron will enter into the K shell. Helium का कितना है? Atomic number 2. Means it has got 2 electrons. Both the electrons will enter into the K shell. Then period number 2. This is this particular diagram shows that lithium. Lithium का atomic number कितना है? 3. So out of 3, 2 electrons first enter into this, and then the next electron will enter into the L shell. So this diagram basically makes your concept more clear how the electron filling is done in the case of period. So now let us go ahead with the next slide. Now see here, this is your period number 1. Period number 1 yani your K shell. You know that for the K shell there is only one and one s orbital is possible, that is s orbital. Now s has maximum capacity to accommodate how many electrons? 2 electrons at a time. Try to recollect that orbital. Orbital में ज्यादा से ज्यादा कितना होता है? 2 electrons रहता है. So फर्स्ट पीरियड का के शेल का सब शेल कौन सा है? ऑलवेज 1, एस, एंड एस हैज अकोमोडेट मैक्सिमम 2 इलेक्ट्रॉन्स एट अ टाइम. सो नंबर ऑफ एलिमेंट्स व्हिच आर पॉसिबल in the particular period is 2. Now see here, this electronic configuration in the first period begins with hydrogen. इसका atomic number कितना है? Z is equal to 1. Z is equal to 1. Your subshell is what? S. so that one electron will enter into the s orbital. So EC is 1s1. Now you will ask me the question from where I return 1s1. See, 1 यानी n value, your period number 1, and s is your subshell. So that one electron will enter into the s orbital. So EC will be 1s1. Now this first period ends with helium. Helium का atomic number कितना है? Z is equal to 2. As it is a first period, again K shell, S subshell, there is only one S subshell is there. So both the electrons will enter into the S subshell. So your EC is 1s2. And therefore, as the S has a capacity to accommodate maximum 2 electron, and for the first period, K is inner shell as well as outermost shell. Therefore, we'll mention that this period ends with the helium with a completed duplet. Now, once the electron filling of the first period gets over, what will happen? The next electron will enter into the next shell of higher energy level as compared to previous period. What I said? When the electron filling of the first period gets over, next electron will enter into the next shell of higher energy level as compared to previous period, which is as per the above principle. Now, what is above principle? Just for the sake of reference, you should know that above principle यानी in the ground state of an atom, electron filling begins with the orbitals of lowest energy first, and then the electrons are filled in the orbitals of higher energy level. Just look at this series. This series you have to by heart in this year only, and you will come to know about this in the detail in the topic structure of atom. But to learn this concept, I have taken this series for the reference purpose for you. So these are all the orbitals. 1s ka energy level is less than 2s, 2s ka level is less than 2p, then 3s, then 3p, and so on. So electron filling is done as per this series. So coming back to your second period, we'll say that second period यानी आपका कौन सा period है? L shell. And L shell has, what is the outermost shell? It has got S and P. Now, S has a maximum capacity to accommodate how many electrons? 2. P has maximum capacity to accommodate how many electrons? 6. Why 6? P orbital में कितना है? 3 है. एक orbital में 2. तो 3 into 2, 6. So, if you make a summation, 2 plus 6, total, how many electrons are accommodated in 2s and 2p? 8. As total 8 electrons are accommodated in the second shell, how many elements are possible in the second period? 8 elements are possible. So the second period begins with the lithium with the atomic number Z is equal to 3. So what about EC? As per this series, देखो पहला कौन सा शेल है? 1s. उसके बाद कौन सा आता है? 2s. So 1s and 2s में out of 3, 2 electrons will first enter into this 1s. They complete its capacity, and that next electron will enter into the 2s. So we'll write 2s1. Now purposefully I have made this 2s1 in the red color and I have underlined this part because this is your outermost shell. ये 2s क्यों आया? आपका second period का चल रहा है. You are learning the EC with respect to second period. तो ये आपका outermost shell है. So 1s2, 2s1 ये आपका inner shell होगा, ये आपका outer shell होगा. So this period ends with the neon with the atomic number Z is equal to 10. Get 10 up, how you will write EC with respect to this series, 1s, 2s, 2p. Now out of 10, 2 electrons first enter into the 1s, fulfill the condition. Remaining 2 will enter into this 2s, fulfill the condition. 2 plus 2, 4. If you subtract this 4 from 10, how many electrons are left out? 6. So that 6 electron will enter into the p orbital. And thus, p orbital से ज्यादा कितना 6 ही रहता है. So all the electrons are entered into this p or subshell or the p orbital. So therefore, if you sum it up, this 2 plus 6, 8. So here we'll say that second period shows or it ends with completion of the octet. 8 electrons are there in its outermost shell. Again, I have make an underline 2s and 2p with the red in color and underline. That shows your outermost shell. So the second period ends up with the neon with a completed octet. Similarly, for the third period, here 3s and 3p is there, but here we have not mentioned 3d because As per the above principle, just look at here. 3D has higher energy level than the 4s. Therefore, instead of entering the electron in the 3D in the third period, it always prefer to enter in the fourth period. So we will never mention the 3D in case of third period. For third period, we'll mention 3s and 3p. I have given you the reason what I have told in the when I'm explaining the diagram. So in the 3s and 3p, again you just count it out. इसका maximum capacity to accommodate 2 electrons, p का कितना है 6, 6 plus 2 कितना हो गया 8. So total 8 electrons are present in the third period. So how many elements are possible in the third period? Total 8. And it begins with the sodium. Atomic number कितना है 11. It ends up with the argon. That is 18. So condensed electronic configuration is neon 3s1 to 2, 3p1 to 6. So argon, this particular period ends up with the argon with a completed octet. Very similarly, once the third period is over, again for the fourth period, as per this, you will find 4s, 3d and 4p is your subshells. So here, S का maximum capacity कितना है 2, D का कितना है 10, because D में कितना orbitals रहता है 5. Each orbital में 2 electrons, so 5 into 2 10. So S में 2, D में 10, P में 6. If you take a sum of this, total how many electrons are present in the fourth period? 18 electrons. Means how many elements are possible in the fourth period? 18 elements are possible in the fourth period. So again, you will mention its condensed electronic configuration as argon 4s1 to 2, 3d 1 to 10, 4p 1 to 6. So the fourth period ends up with the krypton with a completed octet. So this is the way you are going to explain the electronic configuration in the case of period. And it's always you have to remember that we are dealing with the EC in the periods with respect to outermost shell or the principal or the valence shell electronic configuration. So today we will stop over here. And what we have learned, so today in the today's lecture, what we have learned exactly. See, at the beginning in the introductory part, we have learned about what are the different ways have done the scientists to classify the element. That was the basically need. So number is so large, they are not able to identify the properties. So that's why this concept of periodic table was put forth. Mendeleev was the pioneer of this, and how that is law is modified to modern periodic law. Then we have learned about based on that modern periodic law, the complete modern periodic table was there. I told you that number is very important. MCQ आपको आ सकता है. Horizontal rows कितना रहता है 1 to 7 और the 7 periods are there. कितना columns रहता है किती असतात त्याच्यात columns 18 असतात. सॉरी त्याला ग्रुप्स म्हणतो ते ग्रुप्स किती असतात 18 असतात. टोटल एलिमेंट्स आता पण आपल्याला 118 माहिती आहे. सगळ्यांचं नंबरिंग कसं केलेलं आहे IUPAC ने केलंय. मग आपण सर्वात महत्वाच्या कन्सेप्टला गेलो शेल सबशेल ऑर्बिटल्स. त्या डायग्रामला आपण विसरायचंच नाहीये. न्यूक्लियस मध्ये आपला ऍटम्स आहे त्याच्याभोवती एनर्जी लेवल्स आहे स्टेशनरी एनर्जी लेवल्स आहे त्याला आपण शेल किंवा ऑर्बिट्स म्हणतो. मग ते डेसिग्नेटेड एन ने होतात. एन जसा 1 2 3 4 तसं KLMN ह्या त्याच्या काय शेल्स आहे. मग के याने फर्स्ट शेल एल याने सेकंड शेल. मग देन वी हॅव सीन द कॉन्सेप्ट ऑफ सबशेल्स ऑल्सो की कसे 4 सबशेल्स आहेत SPDF. But all the subshells are not possible for the shingles that particular shell. The subshells are fixed for the particular shell. मग K साठी कुठली असते S असते कायम. मग L साठी S आणि P असते. मग M साठी SPD असते. पण इलेक्ट्रॉन फिलिंग घेताना तुम्हाला माहिती आहे अब्बा प्रिन्सिपल मुळे आपण 3s आणि 3p's फक्त घेतो आणि N मध्ये सगळ्या शेल्स असतात SPDA. मग आपण आपल्या EC ला आलो. सर्वात महत्वाचा कन्सेप्ट तुमच्या हा डोक्यात आला पाहिजे की पहिल्या पिरियड मध्ये K शेल आहे आणि तिथे डुप्लेट फॉर्म होतो कारण ते दोनच एलिमेंट आहे. पण त्याच्या ऑनवर्ड जेव्हा तुम्ही जाता तेव्हा सेकंड पिरियड जेव्हा घेता तेव्हा के शेलला विसरायचं नाही बिकॉज के शेल तुमची इनरमोस्ट शेल आहे आणि त्याच्या पुढची आउटरमोस्ट शेल एल आहे. तिथे इसी पिरियड मध्ये शिकताना वी आर गोइंग टू डील विथ द ऍडिशन ऑफ इलेक्ट्रॉन इन द आउटरमोस्ट शेल ऑर द व्हॅलन्स शेल. आणि म्हणून आपण ते डार्क केलंय त्यामध्ये दाखवलंय आपण याच्यामध्ये की सेकंड म्हटलं म्हणजे काय आलं की आउटरमोस्ट शेल ऑर द प्रिन्सिपल ऑर द व्हॅलन्स शेल. And then we have learned about the EC with respect to each period, and we have made the concept of clear. And here you have come to know that why in the first period, there is a duplet condition is satisfied, and first period onwards, how it satisfy the completion of the octet. आणि आपण या सगळ्याचं इलेक्ट्रॉनिक कॉन्फिगरेशन हे शिकलेलो आहोत. So I think let us stop over here and we will switch over I just over to Amol sir for the next lecture, that is your physics lecture. Uh, uh, okay. The thing is what, before I deliver this to hand over these things to Amol sir, I just want to tell that next time we are going to learn about the electronic configuration in the case of blocks, groups, and this one. So please come prepare with all those things. And now we will meet in the next lecture. So over to Amol sir. Thank you very much.
Thank you. Thank you, madam.
Thank you, sir. Uh,
Abhinav, sir.
Abhinav, shall I leave the meeting?
हॅलो.
हां सर.
येस सर, झालं असेल तर आपण मीटिंग एंड करू शकतो.
सर मी मीटिंग एंड करते.
ओके सर.
ओके, ओव्हर टू अमोल सर. थँक्यू व्हेरी मच.
थँक्यू.
एंड करून टाकू
सर. आता फिजिक्सचं लेक्चर आहे.
येस सर, आता फिजिक्स होईल. इथलं आपलं संपलंय.
So should I start? So
yes,
very
sir.
good morning.
Also, you can start.
Yeah. Thank you. Thank you, Prashant sir. So very good morning, dear students. Here I am Amol Jadhav with my colleague teacher, Mr. Prashant Patil from Department of Physics, Kirti College, Dadar, Mumbai. Before I proceed for my lecture, I'll thank to the government of Maharashtra, SCERT, the management of Deccan Education Society, Pune, and of course, my Kirti College to provide me this opportunity to take this online lecture series on SCERT. So I'll start with my PPT presentation now. So students, today I'll start new topic from the first chapter, which is units and measurements. This is very important topic as far as physics concerned. So in this topic, we'll see about dimensions and dimensional analysis, as well as its uses of dimensional analysis. So first of all, what is dimensions? So if you go through the definition, the dimensions of a physical quantity are the powers to which the fundamental unit must be raised in order to obtain the unit of that given physical quantity. Now, in previous lecture, you have studied about the fundamental quantities as well as derived quantities. Okay, so basically we consider there are 7 fundamental quantities. So by using combination of these fundamental quantities, we can find out some derived quantities. And how we find out these derived quantities, it depends on the dimensions of these fundamental quantities. I'll explain you this very simply. So for our convenience, the basic quantities are represented by symbols, as you know this in previous lecture. So we use capital L for length, capital M for mass, capital T for time, K for temperature, I for current, CD for luminous intensity, and mole for amount of mass. These are 7 fundamental quantities, and we are going to use these abbreviations L, M, T, K, I for dimensions and dimensional analysis. Now, I have read this definition कि what is dimensions. तो थोड़ा आपको ये लगा होगा अरे यार ये समझ में नहीं आया. The powers to which the fundamental units must be raised. क्या है ये? तो थोड़ा फिजिक्स से बाजू में हटते हैं. we'll go for a recipe of tea, making tea. आपने घर में चाय बनाई होगी कभी, तो let us consider कि आपको एक चाय बनानी है. तो to make this tea, what are the basic ingredients? The basic ingredients, so physics, in terms of physics, I can say these are fundamental quantities. The basic ingredients which I want, which I use to make a cup of tea are fundamental quantities. और जो मेरी चाय बनेगी, जो चहा बनणार आहे, तो असणार आहे माझा एक डिराइव्ड क्वांटिटी. सो पहिल्यांदा तुमच्या जर हे लक्षात आलं की व्हॉट इज फंडामेंटल क्वांटिटी अँड व्हॉट इज डिराइव्ड क्वांटिटी, then it will be easy to understand what are the dimensions, okay, or dimension analysis. So my fundamental quantities here in this case are the basic ingredients to make tea, and my derived quantity is 1 cup of tea. Now what are these ingredients? So I required water, milk, sugar, and tea powder. So these are 4 fundamental quantities or basic ingredients which we required to prepare a tea. Now, here the proportion of these ingredients is very important. So what is proportion? Proportions means the dimensions of the ingredients. So आपको ये ingredients कैसे proportion में लेना है, पानी कितना लेना है, how much milk you'll take, or sugar or tea powder, these are the proportions. So these proportions are nothing but the dimensions. Okay. Now for example, suppose कि अगर I am preparing tea, so let us consider I want to prepare 1 cup of tea now. So let us consider I'll take water half cup, milk half cup, then sugar 2 spoon, and tea powder 1 spoon, isn't it? So this is my proportions, or I can say these are the dimensions to make 1 cup of tea. So therefore I can write the dimensions of 1 cup of tea like this. So here 1 cup of tea, I have written this in a square bracket. Now this square bracket is very important. We use this square bracket to show dimensions. So I can read this term as dimensions of 1 cup of tea. So this square bracket has its own meaning. So you have to write this square bracket always when you write dimensions. So dimensions of 1 cup of tea is equal to, so my basic ingredients or fundamental quantities, that is water, how much, half cup. Then I'll take milk, how much, again half cup. Then sugar 2 spoon, and tea powder 1 spoon. So this gives me 1 cup of tea. So these are the dimensions. So I think you can now easily understand what are the dimensions. So in terms of physics now, to derive quantities other than fundamental quantities, we use different combinations of fundamental quantities. So जो मैंने बोला था कि these fundamental quantities, 7 fundamental quantities. So basically we are going to consider length, mass, and time. Almost 90% जो quantities है, we can express in terms of length, mass, and time. So we'll first find out dimension of area. Now to find dimension of area, just like T, you should know what is area. Area कैसे बनता है? What is the formula for area? जैसे T के लिए क्या formula था? What are the ingredients? वो आपको पता होना चाहिए. Like this here also. So what are the dimensions of area? To find this, you should know first of all its equation. So equation of area is length into breadth. Therefore I can write dimensions of area is equal to dimension of length into dimension of breadth. Now here length and breadth both are length only. Okay. Therefore now I'll write dimensions of length in terms of 3 basic fundamental quantities, which are length, mass, and time. Now to express length, I required only length. There is no need of mass. There is no need of time. Therefore, I can write dimensions of length as L1 M0 T0. I'll read this as dimensions of length are L1 M0 T0 into dimensions of breadth. Now breadth is nothing but again length. So again we'll consider L1 M0 T0. See, if you get this simple example, then it will be very easy to understand further examples of derived quantities to find dimensions. So here, these are the dimensions for length and breadth. Now, if we solve this by using laws of indices, so here L raised to 1 is there, here again L raised to 1 is there. Therefore, according to laws of indices, this 1 plus 1 will be here. So L raised to 1 plus 1. For M, 0 is here, again 0 is here. So M raised to 0 plus 0. T raised to 0 is here, T raised to 0. So T raised to 0 plus 0. Now we'll solve this. So I'll get this answer. Therefore, the dimensions of area, I can write dimensions of area as L2 M0 T0, or I can simply write L square also. Now from these dimensions, I can find out unit of area also. This is very simple. See, these are the dimensions of area. And now what will be the unit? To find out the unit of area, I'll move to my dimensions. Here, length, 2 times length. So if I talk in terms of SI units, so what is the unit of length, which is meter? But here L square is there, na? 2 times L. So meter square. Then mass is 0. So there is no question of kilogram. Time is 0. Therefore, there is no question of second also. So I'll consider only unit of length because I am having only this quantity, which is length, which is 2 times. So the unit of area is now meter square. Just look at this first example carefully. Here we are using laws of indices. Okay, simple hai. Now we'll move to next, volume. Now again, to find dimensions of volume, I should know its formula or equation. Volume is equal to length into breadth into height. Therefore, dimensions of volume. See, I read this as dimensions of volume. I have used here this square bracket. So dimensions of volume is equal to dimension of length into dimension of length and dimensions of length. So length, breadth, and height all are lengths only. Now I'll substitute their values. So I know dimensions of length are only L1 M0 T0, again L1 M0 T0, again L1 M0 T0. So laws of indices, L raised to this one. Since there is multiplication, so we have to add the powers here. So 1 plus 1 plus 1. So L raised to 1 plus 1 plus 1. Now M raised to 0 plus 0 plus this 0. So M raised to 0 plus 0 plus 0. T raised to 0 plus 0 plus 0 here. So my final dimensions for volume are L3 M0 T0. Therefore, the dimensions of volume are L3 M0 T0. Just like area, you can find out unit of volume 3 times L means length. So here I'll consider SI unit of length as a meter, which is 3 times. So my unit for volume is meter cube. So move to next, which is velocity. Velocity, its formula is displacement upon time. Now again, what is displacement? Displacement is what? Again length. It is a length only. divided by time now. Therefore, the dimensions of velocity are dimensions of displacement upon dimension of time. Therefore, dimensions of displacement are L1, M0, T0. Dimension for time. There is no question of length. There is no question of mass. There is only time, which is one time. So I can write dimensions for time as L0, M0, T1. Therefore, now I'll solve this. So since there is division, now here this 0 will subtract from 1. So powers of L. Here there is 1, here there is 0. So L raised to 1 minus 0, since there is division. Then M minus M raised to 0, M raised to 0. So 0 minus 0. T raised to 0 here, and here T raised to 1. Now this T raised to 1 becomes here minus 1. So T raised to 0 minus 1. So my final dimensions for velocity are L1, M0, T minus 1. Now from this we can find out for unit of velocity. So here I have length, one time length. So SI unit of length is meter. So there is only meter. Now there is no mass. Now here there is time, but time is like this, time raised to minus 1. So I can write per or divided by. So what is unit of time? Which is second. Therefore I can write unit of velocity as meter per second. See, this meter stands for this L raised to 1. Unit of length is meter raised to 1. I have not written here. There is no need to write this M raised to 1. Then second raised to minus 1. T. T means time. Its unit is second. So second raised to minus 1, which I can write like this, meter per second. Or I can write this unit as meter into second raised to minus 1, like this also. Okay. We'll move to next, dimensional analysis for acceleration. Now, formula for acceleration, velocity upon time. Therefore, dimensions of acceleration are dimensions of velocity divided by dimensions of time. Now here I'll directly substitute dimensions of velocity, which we derived previously. So L1, M0, T minus 1, and for time, which is L0, M0, T1. Now again we'll solve this. So L raised to 1 minus 0, M raised to 0 minus 0, T raised to minus 1 minus 1 here. This minus 1 minus 1. Therefore, this becomes L raised to 1, means L1, M0, and T minus 2. These are the dimensions for acceleration. Now from these dimensions, again we can find out unit of acceleration as, now since there is length, so meter raised to 1, there is time raised to minus 2. So I can write meter per second square or meter second raised to minus 2, like this. So this is the unit for acceleration, meter per second square. Next quantity, which is force. Important quantity, force. So the formula for force is mass into acceleration. Therefore, F is equal to M into A. Therefore, the dimensions of force are dimensions of mass into dimensions of acceleration. Therefore, I'll substitute these values. Dimension for mass, length is 0, mass 1 time, T 0 time. Then length for acceleration, L1, M0, T raised to minus 2 or T minus 2. These are the dimensions for acceleration. So if we solve this, we get, now here there is multiplication now. So multiplication, then there will be sum of these powers. So L raised to 0 plus 1, 0 plus 1, M raised to 1 plus 0, T raised to 0, plus minus 2. Plus minus 2 means minus 2. So finally, we get dimensions for force as L raised to 1, M raised to 1, and T raised to minus 2. I can read this as dimensions for force are L1, M1, T minus 2. From this, we can find unit for force. Now here, I have length one time, so meter. I have mass one time, so kilogram. Okay. And time raised to minus 2. So I can write per second square. So my unit for force will be, see, this is for mass. This is not meter, this is mass. So for mass, kilogram. Kilogram meter per second square. This kilogram meter per second square is also known as Newton. So Newton is unit of force, and Newton is what? Kilogram meter per second square. So this is about force. The next quantity, which is work. So again, formula for work is force into displacement. Therefore, dimensions for work are dimensions for force into dimension for displacement. So here we'll directly substitute values of dimension for force. See, you have to remember certain dimensions of length, area, volume, force, velocity, acceleration, and work. You will need this. So you have to remember these dimensions. So dimension for force is L1, M1, T minus 2. Dimension for displacement is L1, M0, T0. So by solving this, we get L raised to 1 plus 1, M raised to 1 plus 0, and T raised to minus 2 plus 0. So we have these dimensions L2, M1, T raised to minus 2. So these are the dimensions for work, and from this again we can find out unit of work, which will be, see, the unit for mass is kilogram raised to 1. The unit for length is meter, but meter square. Here there is meter square. And unit for time, which is second, but second raised to minus 2. So we can write this as kilogram meter square per second square, or we can write this as kilogram meter square second raised to minus 2, which is known as joule. The dimension, the unit of work is also known as joule. Okay, so up to this, I have covered some important quantities, derived quantities, to find dimensions. Now we'll move to uses of dimension analysis. Before that, we'll see a table which is given in your textbook also. So here there are some quantities. Okay, I have not derived their derivation or dimensions here, but it is given in the table. Density, density is what? Denoted by P. Rho है, P नहीं है. M by V. So its dimensions are L3, M1, T0. So its unit will be kilogram per cubic, M cube है ना, per cubic meter square. Acceleration, I have explained this. Momentum, momentum is denoted by P. Here this is P and this is rho. Then momentum P, M into V. Its dimensions are L1, M1, T minus 1, and unit is this one, kilogram meter per second. Then force I have explained. Then impulse, impulse denoted by J. Impulse is equal to force into time. That means dimensions of force into dimensions of time. So we get L1, M1, T minus 2. So its SI unit will be Newton second. Then work I have explained. Kinetic energy. Now we can use these dimensions of energy for kinetic energy, potential energy, any type of energy. Here I have considered kinetic energy. So formula for kinetic energy is half mv square. If we consider potential energy, then we'll consider here mgh. Whatever may be the energy, its dimensions will be same, L2 m1 t minus 2. Okay, so this is SI unit for energy, kilogram meter square per second square. Again, it is known as joule. Then pressure is equal to force upon area. So its dimensions are L minus 1 m1 t minus 2. So its units are kilogram per meter second square, or which is known as Pascal. Kilogram per meter second square is also known as Pascal. Now we'll move to next topic, which is very, very important, uses of dimensional analysis. Now there are three uses, out of which the first use of dimensional analysis is to check the correctness of a physical equation. That means we can check whether a given equation is correct or wrong. So if I say there are three kinematical equation, v is equal to u plus at, or v square is equal to u square plus 2s. So these are equations given in the textbook. That's why those are correct. Or can we check their correctness? So we can check their correctness by using dimensional analysis. So here I'll consider a very simple example of first kinematical equation, which is v is equal to u plus at. Now here, what is v? This v is final velocity. What is u? U is initial velocity. What is a? Acceleration. And t is time. Now, whatever may be the velocity, whether it is final velocity or initial velocity, it is velocity only. So we are going to consider the dimensions of velocities for v and u. Now, there is one principle which is known as principle of homogeneous dimensions. According to this principle says that the dimensions of all the quantities in an equation, if the dimensions of all the quantities in an equation are same, then that given physical equation will be correct. That means in this case, v is equal to u plus at, we have three terms. The first term is v, the second one is u, and the third one is a into t. Remember one thing here, whenever there is plus or minus sign, I can say this u is different term and this a into t, there is a into t, और वहां पर अगर डिवीजन भी होगा तो I'll consider that as a single term. So अगर plus या minus होगा, I'll bifurcate this. So there are three terms v, u and a into t. So according to principle of homogeneous dimensions, if dimensions of this v, dimension of this u and dimension of this a into t are same, then I can say the given equation, which is v is equal to u plus at, is a correct physical equation. Okay, so let us check. So here the first quantity, which is v is equal to, its dimensions of v are L1 m0 t raised to minus 1. This is my first quantity. Then second one is initial velocity. Again, its velocity. Then L1 m0 t raised to minus 1. I have given this equation number 2. Then my third quantity is a into t, dimensions of acceleration into dimensions of time. So dimension of acceleration L1 m0 t minus 2, dimension for time L0 m0 t raised to 1. So if I solve this, I'll get L raised to 1 plus 0, m raised to 0 plus 0, and t raised to minus 2 plus 1. So the final dimensions for a into t are L1 m0 t raised to minus 1. This is my equation 2. Now, if you look at the RHS of equation number 1, 2, and 3, all these RHS means all these dimensions are same, which is L1 m0 t raised to minus 1. Now, since the RHS of equation number 1, 2, and 3 are same, therefore, according to principle of homogeneity, I can say the given physical equation v is equal to u plus at is a correct equation. Okay, so like this, we can find out any equation its correctness, we can check its correctness by using dimensional analysis. Now we'll move to next use, which is to establish the relationship between related physical quantities. Means here we can check how one physical quantity is depends on another physical quantity. Like here I have considered example of kinetic energy. Now here the kinetic energy, let us consider it is denoted by E only, not Ke. I have taken E, capital E only, which depends upon mass, which is denoted by small m, and velocity v. Now if I told you कि kinetic energy depends on mass and velocity, find the exact dependence, कि how it is related with mass and velocity. To find this, we can derive this relation by using this dimension analysis. So here it is given kinetic energy is depends on, means proportional. Kinetic energy is proportional to mass as well as velocity. But how much mass, that I don't know, which I am going to find out. So how much, which is x. So I want x time mass, I want y times v to derive kinetic energy. Okay, and here by using dimensional analysis, I can find out the value of this x and y. So I can find out the exact dependence of kinetic energy on mass and this velocity. So from this equation, I can write, instead of sign of proportionality, I'll consider equal sign. So I have to consider one k, which is constant of proportionality. So E is equal to k into m raised to x, v raised to y. I'm going to find out value of this x and y by using dimensional analysis. Now, equating dimensions on both sides. Now, we'll equate the dimensions of each and every term on both sides here. Now, remember here one thing. We can find out dimensions of the physical quantities, not constant numbers. Here, k is a constant, so we cannot find dimension of k. Okay, so here we'll consider dimensions of E is equal to k into dimensions of mass raised to x. I'm going to find out value of x and dimensions of velocity raised to y. Okay, so k is a constant, we cannot find dimensions of k. So I will simply substitute. So dimensions of energy are L2, M1, T minus 2. Dimensions for mass are L0, M1, T0, bracket raised to this x. Dimensions for velocity L1, M0, T raised to minus 1, bracket raised to this y. Now we'll solve this bracket first. So this x will multiply this 0, again this x will multiply this 1, then this x will multiply this 0. So what we get here? We get 0 into x is 0, 1 into x is x, and again 0 into x is 0. For this bracket, this 1 into y is y, this 0 into y, again 0, and minus 1 into y is minus y. Further, we'll solve these two brackets. So the dimensions in case of L raised to 0, here there is L raised to y. So there is multiplication, so hence there is addition. So 0, L raised to 0 plus y, m raised to x plus 0, and t raised to 0 plus minus y. That means minus y. So here I get powers of L as 0 plus y, power of m as x plus 0, and power for t is 0 minus y. Now, if you solve this 0 plus y means only y, x plus 0 is only x, and this becomes minus y. So this term is here. So I get this one. Power of L is y, power of m is x, and power of t is minus y. Now, by equating the powers of L, M and T on both sides we get. हम लोग ये क्यों इक्वेट कर रहे हैं कि सर हम लोग ये पावर्स कैसे इक्वेट कर सकते हैं? बिकॉज अभी अभी हमने फर्स्ट यूज देखा अकॉर्डिंग टू प्रिंसिपल ऑफ होमोजेनियस डायमेंशंस, सो दिस डायमेंशंस आर सेम, ऐसे वहां पर बताया गया था. सो दैट्स व्हाई वी आर इक्वेटिंग दिस. सो this L raised to 2 here, L raised to y is here. So if I equate, so I will get y is equal to 2. Powers of L मैं equate कर रहा हूं यहाँ पर. So I get y is equal to 2. Similarly, if I equate powers of mass here and here, I'll get x is equal to 1, this one. Similarly, I'll equate this t raised to minus 2, here t raised to minus y. Therefore, I'll get minus y is equal to minus 2. That means, which implies y is equal to 2. So I'll get two values here, value of x and value of y. See here, value of y is 2, here also value of y is 2. दोनों जगह पे सेम ही आएगा, डिफरेंट आएगा ही नहीं. सो आई हैव बोथ द वैल्यूज ऑफ x एंड y जो मुझे फाइंड आउट करना था. सो बाय सब्स्टिट्यूटिंग दिस वैल्यूज ऑफ x एंड y इन इक्वेशन 1, इक्वेशन 1 मेरा क्या था? E is equal to k into m raised to x, v raised to y था यहाँ पर. So if I substitute these values, x is my 1 and v is y is 2. So I get this equation E is equal to k into m raised to 1, v raised to 2. Here, to find value of this k, we can find out this value of k experimentally. So experimentally, it becomes half. So I can write the above equation as kinetic energy is equal to half, which is the value of k. We can find out this value by experiment only. So half mv square. So this is the relation between kinetic energy and mass and velocity. So this is second use of dimension analysis. Now we'll move further. The last use of dimension analysis, which is to find conversion factor between the units of same physical quantity in two different systems of units. For example, you know that 1 kilogram is equal to 1000 gram. So what is the relation between a kilogram and gram? These are two different systems of units. One is in SI system, another one is CGS system. So 1 kilogram is equal to 1000 gram. That means there is a number which is 1000. When we multiply this number to 1 gram, we get 1 kilogram. So this 1000, this number 1000 is here a conversion factor which converts grams into kilogram. So we can find out these conversion factors by using dimension analysis. Here we'll consider an example of units of force. So unit of force in SI system is Newton, and which is in CJ system, which is dyne. So we are going to find out what is the dependence of this dyne on Newton, or how Newton and dyne are related with each other, like 1 kilogram is equal to 1000 gram. Okay, so we can to find this, we have to consider, of course, dimensions of force, which are L1, M1, T minus 2. Now we'll consider कि 1 Newton is equal to X dyne. Like this, 1 kilogram is equal to 1000 gram. So here I don't know 1 Newton is equal to how much dynes. Okay, so I want to find this X. Okay, so here I'll simply substitute dimensions of force here. See this Newton is unit of force. So I'll substitute here dimensions of force. This 1 into dimensions of force are L1, M1, T minus 2. This X into again dimensions of force L1, M1, T minus 2. Now I'll write these dimensions in terms of SI unit. This one LHS वाला जो है, I'll write in terms of SI unit. क्यों? Because LHS पर Newton है, which is SI unit. RHS पर जो dimensions दिए हैं, I'll write these dimensions in terms of CGS unit, because here there is CGS unit, which is dyne. So instead of length, I'll consider unit of length in SI system, which is meter. See here, instead of length, I'll consider meter. Instead of mass, I'll consider its unit, which is kilogram in SI system. So kilogram raised to 1. For time, which is second only. So S raised to -2. On RHS side, I'll consider unit of length in terms of CGS system, which is centimeter. So L raised to 1 means centimeter raised to 1. For mass, gram raised to 1. And for time, S raised to -2. This is very important term. Okay. Here, I have written those dimensions in terms of units in SI system and here units in CGS system. So by shifting X, we get this formula. मला X find out करायचा आहे. X मी एका साइडला नेला. So here I get this meter raised to 1, kilogram raised to 1, second raised to -2, centimeter raised to 1, gram raised to 1, second raised to -2. Now I want value of this X in terms of dyne. डाइन मध्ये आन्सर पाहिजे मला. डाइन मध्ये म्हणजे कसं पाहिजे मला? इन CGS system. So here I'll convert this mass kilogram in terms of CGS system, which I know की 1 मीटर म्हणजे किती असतं मला माहिती आहे. 1 मीटर इज इक्वल टू 100 सेंटीमीटर. सो इकडे मी काय करणार? हा मीटर सेंटीमीटर मध्ये कन्वर्ट करून लिहिणार. आय कन्वर्ट दिस किलोग्राम इनटू ग्रॅम्स, कारण मला फायनल आन्सर कशामध्ये पाहिजे? I want final answer in CGS system. So that's why I'll convert this. So I know 1 meter is equal to 100 centimeter. फक्त मी 100 न लिहिता 10⁻²लिहिलं इकडे. So 100 centimeter. 1 kilogram is 1000 gram. So 10⁻³ gram. Here power C, power, you can check power here. 1 centimeter, 1 kilogram 1 आहे. परत आपण ग्रॅम पण 1च घेतला. We are not going to change these powers. ठीक आहे. मी इथे कोणी म्हणेल इथे 10⁻³ काय? दिस इज 1000, दिस इज 100. ओके, अँड दिस रिमेन्स ॲज इट इज. याला मी चेंज करणार नाहीये. सेंटीमीटर रेस टू 1, ग्रॅम रेस टू 1, सेकंड रेस टू 1. नाउ हियर सेंटीमीटर रेस टू 1, सेंटीमीटर रेस टू 1 will get cancelled. Here gram raised to 1, gram raised to 1 will get cancelled, and second raised to -2, second raised to -2 will get cancelled. So I get here this 10⁻² into 10⁻³, so which becomes 2 plus 3, that means 10⁻⁵. हे सेंटीमीटर वगैरे मी मगाशी म्हणत होतो त्याप्रमाणे कॅन्सल झाल्यानंतर माझा फायनल आन्सर येणार आहे x is equal to 10⁵, जो मला फाइंड आउट करायचा होता. अँड व्हॉट इज दिस x? दिस x is nothing but the conversion factor between the units of force in MKS and CGS system. So if we substitute this value of x in first equation, which is 1 Newton is equal to x dyne, आपण लिहिलं होतं. So I'll substitute value of x as here 10⁵. So 1 Newton is equal to 10⁵ dyne. So like this, we can find out conversion factor between for different physical quantities. So as per time, we can take only one example. Now the last topic for today's lecture is limitations of dimension analysis. Now there are some limitations. This is theoretical part only. The value of dimensionless constant, जैसे मैंने अभी बोला था कि k is a dimensionless constant. Kinetic energy is equal to half mv². वहां पर जो half था, half was k. तो वो जो half का value है, we cannot find out by using dimensions or dimension analysis. तो वहां पर हमें experimentally उसका value find out करना पड़ता है. The second one is the dimension analysis cannot be used to derive relation involving trigonometric, exponential or logarithmic function, as these quantities are dimensionless. So again वही आया कि जहां पर dimensions नहीं या constant है, so we cannot use the dimension analysis. If the correct equation contains some more terms of same dimensions, it is not possible to know about their presence using dimensional equation. To explain this, a simple example we'll consider here. For example, we'll consider this equation. S is equal to ut plus half at². So we have seen the first use of dimension analysis की we can check the correctness of equation. So according to that, क्या होता है? When this equation will be correct if dimension of this S, dimension of this u into t, and dimension of this a into t² will be same. Again यहाँ पर 3 term है. First term is S, second term is u into t, and the third term is a into t². So if dimensions of all those three terms will be same, we can say this equation is correct. लेकिन अगर ये इक्वेशन में से मैं हाफ AT स्क्वायर निकाल दूं तो मेरे पास इक्वेशन बचता है S is equal to UT. Then also I can say, अरे the dimension of S is so and so, the dimension of UT is so and so. Since both are same, I can say S is equal to UT. This equation is correct, isn't it? According to this dimensional uses? No. तो this is the limitation. तो अगर यहाँ पर अगर मैं ऐसे लिखता हूँ, या तो मैं UT को कैंसिल कर देता हूँ, UT नहीं कंसिडर कर रहा हूँ, I'll consider only this much part. तो is this a correct equation? S is equal to half AT square? No. So this is the limitation. Then number 4, this method is not useful if constant of proportionality is not a dimensional. Again वही repeat हो रहा है. So F, I have formula for force. F is proportional to m1 m2 upon r square. Here we consider one constant of gravitation, which is capital G. So here the constant of proportionality capital G is not dimensionless. वहां पर जो k था वो dimensionless था, एक number था. So the value of dimensionless constant can be obtained with the help of, again we can find out this with the help of experiment only. So here we'll stop here today. I'll just recap. We study about what are the dimensions, how we can find out dimensions of derived quantities, then dimension analysis and its uses. There were 3 uses. Okay, so thank you very much. Thank you. Thank you, sir. Abhinav, sir.
Abhinav sir, lecture is over.
हॅलो.
Abhinav sir,
हाँ
physics lecture is over.
ओके सर, यानंतर आणखी लेक्चर आहे कुणाचं?
नाही सर, आजचे संपले.
आजचे संपले?
हो हो, आजचे संपले.
ओके सर, वी आर गोइंग टू एंड नाउ.
या,
थँक्यू ऑल ऑफ यू. छान लेसन झाले आहेत आपले. उद्याच्या साठी आपण आता तयारी करू आणि आजचं हे सेशन आपण एंड करूया. ठीक आहे सर.
Yeah, thank you sir.
थँक यू.